through actually a few groups over a period of time in developing these interfaces for web-based applications and tools for building such these interfaces. As you can see, there are quite a number of people involved in building some of these applications, and what I'm presenting is just a all their collective effort as such. So the first few slides, they're probably all familiar arguments to you by now. So deploying Lisp-based applications over the web requires having more than just a web server. You need additional services such as generating HTML, and what so for that, developing lightweight tools to provide these services turns out to be a good approach. And there is a topic about what these tools are and why they're a good approach. And finally, Common Lisp turns out to be an essential element in producing such tools. The web turns out to be a particularly good medium because it is relatively language neutral, guaranteeing the libraries that you work with, etc. You can just produce your HTML, your JavaScript, your CSS, your style sheet rules, that is, and the browser will then produce your user interface. So in addition, there are a number of things now that are being done over the HTTP protocol besides just serving web pages, such as application integration, and this application running over the web can take advantage of all these new tricks as they appear. So these are four key issues that we identified over the course of building our applications. The first was just generating the HTML. Then this second, managing extended dialogues between with users. So it's in the sense of you present some information to the user sends some information back, you present some more information, and there's a state accumulation as you run through these through the dialogue. Then in some instances we needed to produce custom user interfaces, and for that we generally need to exchange structured data with the server as opposed to just sending a flat HTTP request. And finally, we into our applications we had to integrate external components that had been produced by other programmers at other sites, and these components came with their own user interfaces. So how do you bring together elements from your own application with these with the user interfaces produced by these external components and present it as a composite whole to the user? So the tools we developed were, well, for HTML, we developed what's called active Lisp pages, for which Andres Rodriguez is going to be presenting a separate talk later. So I'll be very brief on this. For managing for managing dialogues with the user, we wrote an interaction manager to help control the flow of pages and the accumulation of data. Developed a simple Lisp-based SOAP processor for exchanging structured data, and for UI integration we used XML and XLT and built an API around these technologies. So first of all, let me first define more precisely what we mean by lightweight tools. So these are the 5 key criteria for us. They should be easy to implement. Their API should be fairly simple. a programmer observing the application in an institution should be able to get an idea of how these tools work in a relatively straightforward way. So a few traces, looking at function definitions, etc., should get a good picture of what the tool is doing. The tool should only focus on the key functionality that it provides, and to the extent that sometimes it sacrifices corner cases. And finally, we don't build an extensive use policy, any extensive model of how the tool is supposed to be used into the tool itself. That's left up to the programmer. The advantages that we found following these criteria is that we get better reuse out of our tools. Some of these tools have been used across multiple applications. Some of them have just been used with one application, and that's because they're relatively new. We get better reliability. That's because they're better focused to solve just a small problem. And the weakly enforced usage policy effectively means that you can grab these, apply them in ways that were never intended, and actually have them do some interesting things at times. So the first view, I will describe the active list pages that's used within HTML. So here's a little AOP script. Now over here, we have the angle percent represents the content within the angle percent is the list script, and everything else is HTML. Now this is a degenerate example because it's a very small HTML page, and most of the page is actually taken up by the script. The reverse is usually true. Most of the page is in fact HTML, and what you want is little bits of list code sprinkled throughout the HTML page. Now, writing it all in HTML gives the advantage that you can very precisely control the kind of presentation that you give to the user. You can develop your page in your favorite HTML authoring tool even, and later add little bits of list code and have everything work as expected. The output that you get from the script is shown below. So in this script, you have two parameters, A and B, that come from the HTTP request, and those get found in the left and then evaluated in the rest of the page and included in the output. So this is the list function that we get from that script, and we just write out the HTML strings, and it's in the list code. So what we get out of AOP is that the scripting model is very similar to a number of other scripting environments, and so that automatically brings a level of familiarity to any HTML page designer. The scripts are small, inserted only where they're needed, and the end presentation is easy to control. The script is compiled into a list function, which makes the execution very efficient, and these list functions, once they're compiled, can be loaded into a run server. So effectively, you can change the script while the server is still up, and the server automatically picks up the modified script, compiles it, loads it into the current image, and you have an updated interface. The limitations, the first one, the content model is not strongly enforced. You can script anything, it doesn't have to be HTML. Now this is, depending on your point of view, this may or may not be a limitation. If you have special needs, if you need to use, for instance, multi-part encoding or something like that, and your interactions with the HTTP server and client, then you have to deal with the HTTP server directly. AOP will not really help with that. And finally, because the use policy, because the content model is not strongly enforced, there isn't much emphasis on locating and reporting syntactic errors in the originating script, which sometimes makes debugging a little bit tricky. But this can be largely simplified away if we have a strict usage policy for AOP, which says keep the scripts as small as possible. That makes tracking parentheses, etc., really straightforward. So next, I'll present the dialog interaction manager. And first, vocabulary that we use for describing our dialogues. A step for us consists of presenting an interface and getting data back out of that interface. So you present a text dialog box, you get the string back out. That's the dialog step. A dialog itself is just a sequence of steps. And the final computation at the end of the dialog is on the data that's been accumulated through the course of the dialog. So each step as it executes, as I said, adds to the state of the dialog. So for instance, if you're computing the parameter of a polygon, you would first ask for the number of sides. That's one step. The second step would be to get the length of each side, and the result would be to add the length of all the sides. So what happens in HTTP, what makes this problem a little bit difficult, is that there is the dialogues and the request-response cycle of the HTTP server don't quite line up. So where so this is the dialog step. The request-response cycle runs from here to here. So this interleaving causes some difficulties. And our solution to this was, first of all, to split each dialog into a pre-phase and a post-phase. So the pre-phase displays the dialog and ends with the HTTP cycle's end. So that's when you ship off the data to the client. And the post step, the latter part of the dialog, retrieves data from the HTTP request that's just coming in, and that's the start of the next HTTP cycle. So what the role of the interaction manager here is that it transfers state automatically from the pre-step to the post-step. This happens transferring to the programmer actually using the interaction manager. And the pre-step and post-step themselves are implemented as rules. So here's an example of what the pre-step and post-step functions might look like. So you come from the preceding step into the current step. The first thing that you do in the current step, the interaction manager executes the function that's the pre-step function for the accept side count step. After the execution of this function results in some content being produced that's shipped off to the client. The client returns a response to the server, and that's when the post step is executed, and some computation takes place, and you select the next step to execute. And thus the dialog continues. So we have the start of the dialog, the accept side count step, and then the accept side length step, and then you produce your final parameter value. What the interaction manager advises is that the steps in dialogues can be assembled relatively easily, and so you can flexibly modify the flow of information in your application. Dialogue altering becomes a matter of writing the right functions, essentially. It takes a little bit of more tweaking than that, but it's basically just writing functions. And this is very familiar to programmers, and the compiler does most of the error checking. It smooths over the overlapping of the HTTP request response cycle and the dialogue step structure. And in our current implementation, the dialogue state is tracked on the client side for the most part. A few things that we didn't do deliberately is that we didn't have an explicit declarative syntax for describing how these dialogue steps can be put together and people could have done that. Instead, what we chose to do was that we just put the structure of the dialogue within the post-step functions themselves and the pre-step functions. So this causes the dialogues to be relatively hard-coded, but that hasn't proven to be an issue to this point. The presentation of, so the selection and the execution of steps and the processing of data in these steps is somewhat decoupled from the actual presentation of the dialogues. So if you have a lens count that you want to, the side count that you want to track between the accept and the accept side count step and the accept side lens step, then you actually have to put the side count manually into the HTML page. This is a little bit error prone, but again, it's something that's not proven to be a problem. And the dialogues are, each step is very fixed, it's not extensible. You cannot have one step that accepts a string and a second step that derives from it that accepts a number. Third, we have the SOAP processor. SOAP is standard for doing remote procedure calls over the HTTP protocol. And our SOAP implementation uses LXML, which is an encoding of XML in Lisp. So the raw SOAP string that comes in is parsed into this LXML format. And this LXML format then is matched against a set of patterns that are described as rules. And so using a combination of XML as S expressions and these rules that can match over S expressions, you get a very concise representation of what the SOAP, of how the SOAP message should be processed. It's not the most efficient approach, but it is very brief, and it also allows for incremental development of the SOAP processor. So if you want to handle another case in your SOAP processor that your application turns out to need, you add another rule or two rules, and you're good to go. What SOAP brings us is the ability to communicate with custom interfaces and with other applications. We haven't really had to integrate with other applications, but we do have a custom graph editor, for instance, that works quite well with SOAP. We get to reuse the HTTP infrastructure in the application. We don't have to go and yet another RPC protocol along with its network baggage and so on. And there is a published standard. It's not clear whether it will guarantee interoperability, etc., because it's brand new, essentially. But we can at least hope to use it as time goes on. The difficulties that we have encountered with SOAP is that it is a large, complex standard. As much as they want to say that it's simple, it isn't. It's encoded in XML, which makes it extremely verbose, and some of the messages that we are passing back and forth turn out to be in the order of a megabyte in size. And even then, we are limited to a single function call on the server side from the client and a single result value. Finally, there's the integration of external component user interfaces into our server. So let me first give you some intuition behind this, because it's probably one of the least clear things that we ran into. Our server has our application is built around a knowledge base, and into this application we plug in a variety of components, such as one for process simulation, one for analogical analogical reasoning, etc. And each of these components themselves operate over data that is in the server, and so the final UI that they present has the for instance, the analogical reasoning system would have its analogy presentation, and within the analogy it has to present data about the various pieces of knowledge from the knowledge base that it's actually comparing. So the analogy presentation is under the control of the component, while the individual objects in the knowledge base are under the control of the server. So this produces an interleaving that is, it turns out to be fairly subtle, some of the issues that you can run into. So what we want to do is to bring in these component softwares and integrate their UI into our application. The application defines the overall look and feel of the UI, but the component has to be able to work within that framework to produce its own interface. And finally, the two, the server and the component, are largely developed independently at entirely different institutions by different teams of programmers. So there has to be a fairly, the bandwidth between the two institutions is relatively small. So the coupling between components has to be relatively loose. So what we did was we built an API based on XML and XSLT for allowing the components to present their own user interfaces within our server architecture. The application, that is our server, provides an XML template that that includes a standard request and response encoding of what of the data that needs to be presented. This template is generated by macro, and in turn, the component calls functions within the server to allow the server to include its own data in the component's presentation. So for instance, for analogy, what would happen is that you would, so the application would first present its, the application would first write out its template, then the analogy processor would take over and write out its results, and when it ran into a KB object, it would call an API into the server to write, to allow it to write out the XML corresponding to that object. And then the next part, once you have the XML, is to actually produce HTML from it. And for this, our application provides an XSLT style sheet that transforms the template part of the XML response into a standard header and footer. Then it hands over control to the component's XSLT style sheet, which produces the bulk of the interface. And then the component can finally use some pieces of the server style sheet to render the individual objects in the server. So here's where I tried to put together an example to demonstrate the process pictorially. So the parts in white are produced by the server, and parts in gray are produced by the component. The top part is the XML document, and the bottom part is the HTML interface that's produced. What happens is that the template is transformed into a standard header and footer. The component XSLT then takes over and produces the actual list of similarities and differences that the analogy processing found. And then finally, you have objects in KB, which in this case, there's a particular cell in KB that needs to be described in the user interface. And that's transformed into an English fragment for presentation to the user. So what the XML XSLT API has given us is the component requires relatively little knowledge of what's going on in the server. For the most part, the server interfaces are produced through ALP, which I presented earlier. But ALP for using ALP, the component authors would have to know a lot more about how the server operates. This way, you can shield them from most of the details of what happened in the server, and they can just concentrate on how to write their XML output. The component authors can independently verify that their XML, the XML that they're producing is valid, and the XSLT that they have is valid, and they can actually see something in the final output. We don't have to be at all involved in this process. And finally, we also happen to get some efficiency benefits from the server, because the web browser, the client, is now responsible for translating the XML to the HTML. We've had let's see, there are two browsers right now that I know of that support HTML well. from the transformation process flow. The only downside that we really found is that there is a significant amount of upfront work that's required in setting up the communication between the component developers and ourselves. And it's, but once that's done, it's small hurdle. It's not really an issue again. So once again, to reiterate, the common features that we've had in the tools that we've developed are that we've chosen the simplicity of the design as the primary criteria, and to get these designs functional and effective, this has played an essential role for AOP and the interaction manager. There is a significant amount of introspection that's required on the part of the tools. And for the SOAP and XML integration, we make a significant amount of use of macros and dynamic context and so on to actually get this software operational. I suspect that if we were to try to do this in a language like Java, the code would be about probably 4 times as large, or it would be about 3 times as large. We've got applications deployed and under development and that have been built on these tools. So this is an effective strategy. We've been able to verify that. And in conclusion, this strategy of building lightweight tools has given us code that's reusable, maintainable, and is relatively easy to quickly construct a functional application that runs over the web. And this was a key element in building these tools and these applications. Thanks. Questions? Yes?
I just wonder if you're aware of the work that has happened on original products and that's what we're on 91 when they replace these for saying browser. Because you don't want to get access to the source code, but they have to do the same things. So that way, we're not accessing all at all.
No, not really. I'm not familiar with that work.
Paul Dragon's work.
Yes, I do know something of Paul Green's work, but again, these tools were unfortunately not available to us. We had to roll our own out.
Agreed. There should be an intellectual sharing section. It's all in particular. It's not free software, but it's free interchange.
Yes. Well, we aren't sure exactly how we're going to do this, but I would like to make some of this code available for others to use, but that will probably take a little bit of time. SRI is a relatively large organization with some rules and procedures, and we're a small team. There's lots to do in our hands. Yes?
I just would like to make a question. My problem with this kind of approaches for web-based applications is that the server is responsible for doing all the work. Isn't it possible in your setting or how? Would it be possible to move part of the computation to the client side? And being the client responsible for maintaining a lot of state, because in many interactions with the server, there is really no need to have those interactions. I mean, in the example you said about computing the length of a polygon, perhaps asking for the number of sides and the length, all that could be done in the client side, and only the result of the perimeter could be sent to the server. Have you any kind of solution to make some computation in the client side and some in the server side?
Well, okay. Now, if we were to try to do, first of all, this is a fairly simple example. It's just illustrative. We've got more complex things happening in our server. We have to deal with things like, okay, the user enters a string. Is it a class or not? What kind of class is it? What kind of data do we have for it? And based on those kinds of considerations, we select the next step to display to the user.
Yes, but that is maybe in server side, right?
Yes.
But couldn't it be done in the client side?
You need the entire KP at the very least at the client side, and which with a web client, that's just not possible.
Sorry, you will need what?
You need, at the very least, you need the entire knowledge base on the browser.
Well, actually, I have done one simple experiment that turned out to work pretty well, which was in the client side we have a network which is written in Java, but a zero-dimension network, and the output is responsible for producing the HTML code that the browser shows, and so most of the interactions that are commonly done with the server are done through only inside the browser, because when the user clicks on the button, we have JavaScript code that sends that request to the output decides, well, can I produce the next step in the dialog? Yes, I can. Then it produces the HTML necessary to show the next step, and if the output decides, no, for this I need help from the server, then it sends information to the server, and the server sends back the response, and the output continues. But it's the output in the client side that is responsible for producing all the HTML. As a matter of fact, the output was written in Linux, if I presented yesterday, so it was maybe in Linux also.
Okay, there are a couple of issues that we run into there. One is we have to maintain two different pieces of code, even if both of them are in the syntax and so on. There are still two different pieces of code, and we have to maintain them independently and to some extent replicate functionality across them and so on. The other thing is that if we are building a multi-user system, then there is the problem of stale data that you have to deal with if you've got a distributed system. What you're proposing over here is a relatively fat client and distributed data, which turns out to be a hassle. I guess time for one more question. Okay.
Yeah, the thing that concerned me was when you showed the code for an ALP example, and you had a syntax that was non-resident with square brackets. And you said, well, headers and pages to debug because you get really unbalanced. Why did you choose to do this rather than have a list-like syntax and say you make body, I don't know, a simple macro or something, and the parentheses this way?
I guess we never really thought about that, but in this case, what we have is a relatively simple string-based parser, which just has to search for those angle bracket percent patterns and extract this expressions that occur within them, and reassemble things, those things into a list function at the end, and that turns out to be a really simple solution. And Now with simple macros, what you're suggesting?
Well, as a for instance, or wrap the whole thing with HTML macro that just notices things like body and head.
Oh, you mean use
special?
Use something like HTML gen, you mean?
I don't know HTML gen.
Oh, okay. HTML gen has an S expression syntax that goes colon HTML something something colon body something something.
Yeah.
And it's all in S expressions. The problem there is that if you want to hire a person that specializes in dealing with HTML-based web interfaces, you're not going to get this syntax. I mean, that just turns out to be really, it's a problem.
But they can manage these embedded angle bracket percents and bits of this inside those.
They're more comfortable with that because they've seen that before in GSP, for instance.
Well, it's a sad place, isn't it?
I guess we're out of time actually, but we can always talk about this.